Hi, everybody, and welcome to Chapter 5. Here, one of the more complex chapters, and I'm going to spend a little time on this chapter to make sure you guys have got it. Here, we're looking at accounting and the time value of money. Okay, so after we look at this chapter, you're going to be able to see how we do future and present value type problems. And then look at future value of an ordinary and an annuity due problems, and then solve present value of an ordinary and annuity due problems, and lastly, solve present value problems related to deferred annuities, bonds, and expected cash flows. I'm going to be working very hard to make sure that you not only can do this mechanically, but have an understanding of the arithmetic that goes behind this, which I think will help you in applying these concepts. And so, first of all, we'll look at the importance of time value of money. I think it's going to be helpful for you whether you're doing business type work or personal planning. I use it all the time. Understanding how interest works here and how to solve compound interest problems. So as I look at Chapter 5, we're going to look at the future value of a single sum. Sometimes I call that an amount. Then we're going to look at the present value of a single sum. Sometimes I call that an amount. And then solving for other unknowns in single sum problems. Then we'll bounce to annuities. We'll look at the future value of an ordinary annuity, the future value of an annuity due, and then solving for unknowns in future value of annuity problems. Okay, then we'll take a look at solving for the present value of an annuity, ordinary annuity, and then the present value of an annuity due, and then solving for unknowns in present value of annuity problems. And then there's going to be other time value of money issues here. Deferred annuity, valuation of long-term bonds, and the present value measurement of those. Okay, let's take a look at the fundamental concepts related to the time value of money. Here, there is a relationship between time and money. And I think you would know instinctively that a dollar received today is worth more than a dollar promised at some point in the future. So we're going to show you the arithmetic for how we do that. And when deciding among investment or borrowing alternatives, it's essential to be able to compare today's dollars and tomorrow's dollars on the same footing, lovingly called comparing apples to apples. All right, so how do we use this time value of money, present value based accounting measurements? Well, there are several applications. Notes with the bank, leases, pensions and other post-retirement benefits, long-term assets, stock-based compensation, business combinations, disclosure, and environmental liabilities. Also, the payment for the use of money, the excess cash that we receive or repay over the amount lended, or borrowed, the principal. Okay, so we have variables in our interest computation, which I think you probably would know. We have our principal, that's the amount that we borrow or invest. We have an interest rate, that's the percentage of the outstanding principal that we pay for the use of that principal. And then time, the number of years or fractional portion of a year that the principal is outstanding. Okay, so the interest is computed on the principal only. So here, Hill Farm Company borrows $10,000 for 1 year with simple interest of 6% per year. What's the total interest to be paid by Hill Farm? So very easily, here is the equation. We take the principal times the interest times the number of periods, P, I, and N, and then we'll take this $10,000 times 6%, and that for 1 year, so that's going to be $600. Pretty easy there. Okay, interest computed on the principal only, we call that simple interest for 3 months. So let's illustrate here. Hill Farm borrows $10,000 for 3 months at 6% per year. What's the total interest? Same formula. But this time we take $10,000 times 6%, that's our $600, but we only borrowed it for 3 months here. So we take 3 months as a percentage of 12 months because that $600 was an annual amount, and that gives us the interest of $150. Now that's pretty easy, and I think you've had that as review. Now, compound interest is a little different. So here we have the principal, and then we have the interest earned that has not been paid or withdrawn. And so our typical interest computation is applied in business situations all the time. And here is a simple versus compound interest problem. The Vasquez Company deposits $10,000 in the Last National Bank, where it earns a simple interest of 9% a year. It deposits another $10,000 in the First State Bank, where it earns compound interest of 9% per year, compounded annually. In both cases, Vasquez will not withdraw any interest until 3 years from the date of deposit. Okay, so if I look at the first example here, where it's earning simple interest, it's $10,000 times 9%. That's going to be $900. It's going to earn $900 in each of those 3 years. So I'm going to start with $10,000, add 900 to it here, add another 900 in year 2, and add another 900 in year 3. The interest is not earning any interest. We're not getting interest on the interest. But the First State Bank here, here we start out with $900, but that $900 is going to earn $81 of interest in the second year, 9% of $900. And then again, it's going to earn interest on that interest in the third year. So our total is going to be $12,950 versus $12,700, a $250 difference. So what that shows you is compound interest uses accumulated principal plus the interest to date at each year end to compute interest in the succeeding year. That explains the larger balance in the compound interest account. Okay, we'll start here with the future value of $1. If I look in the book on page 5-60, you're going to find these tables. It starts on page 5-60. The first table shows you the future value of $1. The second shows you the second table shows you the present value of $1, which I will explain here in a few minutes. The third table shows you the future value of an ordinary annuity, and then table 5-4, shows you the present value of an ordinary annuity, and then table 5-5.5, I should say, present value of an annuity due. Okay, the number of periods are the number of years or the number of compounding periods per year. So a compound period interest rate is the annual rate divided by the number of compounding periods per year. So that if I had a 12% annual rate and I was doing monthly interest, my monthly interest would be 1%. That would be 12% divided by 12 periods. Okay, so here is an excerpt from Table 5-1, and I'm going to show you the arithmetic for this in a few minutes. Anyway, here's our 4%, and here's period 1, and this is annual periods here. So 4% here, but you'll notice this is not 1.08 here. This is 1.08160. This is allowing for the compound interest. So I'm taking 1.04 times 1.04 times 1.04 times 1.04, etc. So if I were to put $1,000 into an account at 4% for 5 years, at the end of that 5 years, I'm going to get $1,216.65. I will have earned $216.65 in compound interest at that time. And so the table will show you those rates for several percentages. Okay, I'll show you the arithmetic for this in a second. When I first started, this was a little overwhelming, especially as you get into the others. But I think when you see how I do it, it'll be much easier to understand. So here's the future value of a factor for n periods at I interest, right? Here's n and I here. And that's going to be 1 plus the interest rate times the number of periods as an exponent. So in my last example, that was 1.04 times 1.04 times 1.04. You get the idea. All right. So now, if the frequency of compounding is going to determine how much money I have, the more frequently I compound, the bigger my number is going to be at the end. So annually, I'm just taking 12%, right? 5 years times 1.12 times 1.12 times 1.12. But here, semi-annually, I'm going to use the same 12%, but divide it by 2. That'll give me 6%. And then the number of periods will double. So that's going to change. And if I do it quarterly, I divide by 4. I quadruple the amount of periods. If I do it monthly, I get 60 periods over 5 years. Okay, so if I look at that number for a second, here, I think you'll see 8% compounds to 833 if I do daily. If I do monthly, it's 830. If I do quarterly, it's 824. If I do semi-annually, it's 816. If I only do it annually, it's 800. So key to know when you're looking at that if the interest is, if 9% annual interest compounded daily is going to provide you here with 9.42% yield. Key term, yield. Okay. I think this is a good place for us to stop this video. And when we return, we'll look at computing some simple and compound interest. But before I get into that, I'm going to walk you through a simple schedule that I've prepared that's in the modules that'll help you understand that. It's in Excel, and I think it will start to give you an idea as to how to do the arithmetic, etc. All right. Until that time, bye for now.